Here are a couple extra problems I made for the videos to help you with your test over circle segments. So there's a couple of problems on the test where you're going to have a figure that has two unknowns that you're going to have to solve for both variables. So I just wanted to give you a couple examples. We've done a few like this in class, but just wanted to give you a couple of extra examples here. So in this first scenario, we have two secants and one tangent that are all intersecting at the same external point out here. So again, that relationship is going to be a whole times external. So you have two unknowns, a y and an x. So you're going to solve for each one of those individually. So the y is part of this secant. Obviously, you're not going to use the secant that has another variable with it. You're going to be using the tangent that it intersects with to find your y value. So for this secant, the whole length of that secant would be the 15 plus the y, not 15y. You add those parts to get the whole. So you have 15 plus y, and you're going to multiply that by the external part, which is just y. For the tangent, you're given the length of it is 10, so the whole and the external are both 10, so 10 times 10 or 10 squared. So when you distribute your y, you get 15y plus y squared on the left side, and 10 squared is 100. So here's another problem where you have a quadratic that you're going to have to factor. So when that occurs, you're going to want all three terms on the same side set equal to 0, and you want to put it in standard form, which means put the y squared first, then the 15y, and then bringing the 100 over is done by subtracting 100 from both sides. So you would have minus 100 equals 0. So this is the trinomial you need to factor into its binomial factors that will be multiplied to set equal to 0. So of course the first terms need to be each a y so that they multiply together to get y squared. The number part you want to multiply together to get a negative 100. So when you're looking at all the different pairs of numbers that multiply together to get 100, you have, let's see, have I missed any here? 4 and 25, 5 and 20. And then we have 10 and 10. And I think that's all the numbers that multiply to get 100. You want them to multiply to get a negative 100, so your signs are going to be different. A negative 1 and a positive 100, or a positive 1 and a negative 100. You want the sum to be a positive 15, so you're looking for the numbers that have a difference of 15, which are your 5 and 20. So since you want a positive 15, you want your 20 to be positive and your 5 to be negative. So this would be y minus 5 and y plus 20. So using the zero product property, if these two things multiply to get 0, then either the y minus 5 equals 0 or the y plus 20 equals 0. So solving those equations, we get a y value of 5 or a y value of negative 20. Since that's not possible to have a negative segment length, your y value is your positive 5. So now when we look at solving for the x, of course you don't want to use a number that you came up with if you can keep from it. So this secant, I'm also going to be using the tangent to go along with it to solve for the x. So the whole length of this secant with the x is the x plus 5 that we're going to be multiplying by the external part, which is the 5. Put that binomial in parentheses to remind you to distribute. The tangent, the whole length, times the external is again the 10 times itself, or 10 squared. So distributing the 5, you get 5x plus 25 equals 100. Subtracting 25 from both sides gives you 5x equals 75. And dividing both sides by 5 gives you x equals 15. So there's your x value and your y value from the same problem, and you don't have to use one to find the other. Now in this second example, you have a chord here intersecting a secant that is intersecting a tangent. So you have two unknowns in this problem that you are going to have to use one value to find the other. So you can find your value of x first by focusing in on this chord, which is part of the secant, intersecting this chord. inside the circle, so that gives you a part times part relationship to find x. So you'd have the 5 times the 12 equaling the x times the 6. So 5 times 12 is 60, x times 6 is 6x. Dividing both sides by 6 gives you an x value of 10. You're going to have to use that x value in order to find your y, because the tangent is intersecting this entire secant here. So you have to know that part in order to solve for y. You can't have two unknowns. So the whole length of this secant is going to be the 10 plus the 6 plus the 4. So you have a total length of 20 for that secant. So you're using a whole times external relationship since these intersect outside the circle. So your whole length is 20 times the external part, which is 4, equaling the whole times the external of the tangent, which is the y times itself, or y squared. So we have 20 times 4, which is 80, equaling y squared. 80 is not a perfect square, but I put up here in the directions to, if necessary, round to the nearest tenth. So when we take the square root of both sides, we would simply put the square root of 80 in our calculator and approximate that to the nearest tenth, which is approximately 8.9. So you might want to watch this video again, especially if you're needing a little extra instruction on factoring or how to have to use one value in order to find the other.